So we've been talking about relations in this unit, and we talked about how to show relations using a scatter plot. And then in the last lesson, we talked about how to recognize linear and nonlinear and whether there was no pattern at all in data. Okay, so now the next step is we're going to focus on linear for the rest of this unit. Some of this is like from grade 10. Okay, but it's more problem solving than it is pure math. Like you guys learned how to find equations of lines in grade 10 by using certain formulas. We're not doing that. We're doing like sort of relevant problems and coming up with equations for it to help us make predictions. So hopefully you know what an equation is. It's just a mathematical sentence that has some stuff on this side, it's got an equal sign, and has some stuff on the other side. And the stuff is usually letters, lowercase letters, some numbers, some operation signs, sometimes exponents. Okay, and those letters we call variables. And really, equations just let us find information. And you guys have been dealing with equations for a long time. We've been dealing them since the beginning of the year in this course. Like this was one of the very first formulas we talked about. The interest on investment or interest on a loan is equal to the principal amount times the rate of interest times the time. So this one is made up of all variables. Sometimes there may be numbers in there and operations. And so we're just going to talk about the different ways that you can show linear relations. And one way is using an equation. Another way is just using words. And another couple of ways we've already done is using a table and then using a graph. So we're going to talk about those 4 ways to show linear relations. So for example, Emma Ploy is paid an hourly rate of $15. During the first week of November, she works the following hours: Monday 6, Tuesday 8, Wednesday 0, Thursday 4, Friday 5. How would you express this in words? So in other words, like, how do we what do we do to calculate her pay? What do we do? Hours times 15, right? So her gross pay, her gross pay is $15 multiplied by the hours she works. So that's how we would write it in words. But that's a lot to write. So in math, we use shorthand. And what's shorthand for writing in words a lot? Writing equations. Oh, sorry, shouldn't say her gross. How about her gross pay? So how do we translate that into an equation? Well, her gross pay, which is one variable, so we're going to call it P, capital or lowercase, doesn't matter, is equal to 15 times the number of hours she works. Instead of writing hours, we'll just write H, because we write this as a letter and this as a letter because the amounts can change. The hours change, therefore the pay changes. But we don't write it like this using proper algebra. We just put these two together, like so. So our pay is equal to 15H. And we can use that to graph this relationship. But before we graph it, we can put some numbers in a table. Well, we're actually given some numbers here. We're told on Monday she works 6 hours, Tuesday she works 8, Wednesday she doesn't work at all, Thursday she works 4, and Friday she works 5. So I'm going to take all that information and I'm going to put it in a table. So this is going to be number of hours worked. That's actually going to be our independent variable. And our dependent variable is going to be gross pay, because the gross pay depends on how many hours she works. And we were already told the hours. We were told Monday, Tuesday, Wednesday, Thursday, and Friday. So it says she worked 6 Monday, 8 Tuesday, 0 Wednesday, 4 on Thursday, and 5 on Friday. So how do we calculate the pay? Well, we use the equation from the previous page. We just multiply all these by 15. So 6 times 15 gives me $90. 8 times 15 gives me $120. Well, 0, she gets paid 0. 4 times 15 gives us $60. And 5 times 15 gives us $70. Another way to show a relation. And we talked about this when we were talking in the previous lesson, that we can show relationships using a table of values. And if we can use a table of values, that means we can graph it, which is another way to show a relation. But remember, we're talking about linear relations here. What are linear relations? As one variable goes up by some amount, the other variable goes up by a consistent amount as well. That's what it means. Or in other words, if you graph it, it forms a line. So as a graph, well, we want a title. So we'll just say gross pay versus hours worked. Always need a title when we do a graph. And then we want to draw our axes like so. The independent variable always goes on the bottom. So in this case, the independent variable is hours worked. And the dependent variable, because we talked about dependent before, is the gross pay, which goes on the vertical axis. Remember, we want to start at 0, both going this way and this way. Sometimes we use a squiggly line if the numbers are bigger, but it doesn't look like we have to do it in this case. Look at the numbers that we have to make sure we have for hours worked: 6, 8, 0, 4, 5. Wouldn't it make sense to go up by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. We could have gone up by 2s, would have worked as well. What's the scale you want to use on the vertical for the pay? We've got to start at 0 and it goes up to 120. What do you want to go up by? 10? Do we have enough? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Not enough. So instead of 10s, let's go up by 10s is not enough, so we're going to have to go up by more. What's another easier number to go up by after 10s? 20s. 20, 40, 60, 80, 100, 120, 140. We can stop there. So we plot the amounts. And we have 6 hours, 90 dollars. 8 hours, $120. 0 hours, $0. 4 hours, $60. And 5 hours, $75. Remember, these are linear relations we're doing. So all of these ones we plotted should form a line. Which they do. So you should be familiar when you're given a situation to write the relation, linear relation in words, how to calculate the dependent variable given the independent variable. You should be able to write it as an equation, put it into a table, and then graph it. Those are the 4 things we're going to talk about. 2 types of linear relations. Okay? Notice this one goes through the point 0, 0. Sometimes they don't. Sometimes they may start up here. Like maybe she gets a bonus of $60. And then she gets paid 15 bucks an hour. So then it would look something like this. Still linear, but it just doesn't start at 0, 0. If it goes through 0, 0, we call it direct variation. As one goes up, the other goes up by a corresponding amount. If it doesn't go through 0, 0, but it's still linear, we call it partial variation. And we're going to talk about those 2 in a second. Actually, we're going to talk about direct variation right now. So it's linear because as the hours, like if we increase the hours by 1, the pay goes up by 15. That's linear. As one increases by some amount, the other increases by some corresponding amount. And then when the hours worked is 0, the pay is 0. Okay, which means the pay is directly proportional to the hours worked. Which means if you don't put any hours, you don't get any pay. Okay, and that's called direct variation. And the easiest way to recognize something as direct variation, it always goes through 0, 0. That's how you can tell the difference between direct variation and others. So these are the characteristics. The graph is a straight line because it's linear. It has to be a straight line. The line passes through 0, 0. And the graph increases as you move right. On the horizontal axis. Okay. All of those, if it meets all those conditions, It's a direct variation. A direct variation always looks something like this. One variable equals some number times another variable. There's nothing else in the equation. There's nothing after. If you see an equation that looks like this, that just has those things in it, automatically you can say it's direct variation. So like if I said C equals 7n, that's direct. But if I put something after it, that's no longer direct. That's a different type. So direct, it just has that. One single number in it and two variables. And we give that number a certain name. We call it the constant of variation. It's the number that we're multiplying the independent variable by. So here, this would be the dependent variable because the cost depends on n, or C depends on n. The constant of variation would just be 7. It's the number in front of the variable on the right. Here, the constant of variation would be 15. Okay, that's it. So looking at another example, the cost of bottled water, and we're going to call cost capital C, varies directly, so that means direct variation, with its volume. Okay? Which one's independent, which one's dependent? Which one can we control? The volume or the cost? The volume, right? And the cost changes depend on what the depending on what we choose as the volume. So this would be the independent. This would be the dependent. So to write it as an equation, we write the dependent. Actually, I'll just write it right out. The dependent variable equals the constant of variation times the independent variable. That's what a direct variation equation looks like. So we've established the dependent is the cost, so we would say C instead of dependent. The constant of variation is 2. And the independent, that's the volume, which we are told to call V. So that's the equation. What do you think the 2 represents? Cost equals 2 times volume. What do you think the 2 represents? Yeah, that's one, yeah. Or the cost is like, say, $2. The cost for a bottle of water is $2, or say the cost for if this say was 1 liter, the cost would be $2. If it's 2 liters, it would be $4. So it'd be the cost of 1 unit of water. Let's put it into a graph again. So we've got our independent first, so our volume, and then our dependent, which is our cost in dollars. And volume is V, cost is C. Or does it say liters? I think it says, oh yeah, it does say liters. So I'm going to say volume in liters. So basically the 2 represents how much a bottle of water costs, or a bottle of water costs $2 per liter. But notice we're not given the information this time. We have to come up with numbers. So, I mean, really, there's really no incorrect answer here. It's always a good idea to put 0, because then the cost is 0, because it's a direct variation. And I mean, we could go up by ones, 1, 2, 3, 4. We could go up by 2s. We can by huge liters. We could go up by 5s. There's really no incorrect answer here. Okay, so why don't we, I think I went up by 5s in my notes, but why don't we go up by 2s? Again, if you see this and you are asked to fill in the numbers, if you put in 1, 2, 0, 1, 2, 3, 4, you're correct, because it makes sense. If you put in 0, -1, -2, -3, -4, well, that doesn't quite make sense. Okay. So what's the cost for 2 liters? $4. 4 liters, $8. 6 liters, $12. 8 liters, $16. That's if we decided to use 0, 2, 4, 6, 8. And now let's graph it. Title. Cost of water versus volume. We could put. Axes, including labeling them. Independent always goes on the bottom or horizontal. So we've got our volume down here in liters. And then here we've got our cost in dollars. And we have to start at 0, 0. Well, it's pretty easy to see how much what the scales are. I mean, we chose 2, 4, 6, 8 on the horizontal, so let's just go 2, 4, 6, 8. And then the values we got on the vertical were 4, 8, 12, 16. So let's go up by 4s. And then all we have to do is plot these points. Like so. And notice it is a direct variation because the graph goes through 0, 0. And that's also a straight line, and it also increases as you move to the right along the horizontal axis. And here, this last thing, what does the constant of variation represent? Well, it's the cost of 1 liter, or cost per liter, or cost of 1 liter of water. $2. Or we could say it's the cost per liter. That's fine too. So that's still linear. It's just a direct variation. Last thing, partial variation. How do you tell the difference between partial and direct? Partial doesn't go through 0, 0. Or in the equation, partial has something added to the constant of variation. Okay? Just like I said, direct variation, you've got one variable equals constant times another. Partial, you've got one variable equals constant times another, plus or minus something. So let's look at this example. She's paid 15 bucks an hour. She gets a bonus of $50 each day for travel expenses. So we had her original equation as this. She gets paid 15 bucks an hour. But now she gets an additional $50 a day. So not only does she get paid the 15 bucks, she gets 50 bucks as well. This is a partial variation because we've added something to it. And when we're going to see when we graph it, it doesn't go through 0, 0. So we did it using an equation. This is doing it using words. Table of values, very similar to what we did before. Hours worked. Gross pay. And let's just pick the hours. Again, let's do 0, 0. Or sorry, it's not 0, 0. My mistake. If she works 0 hours, how much does she get? 50. What would be, okay, so now what would be reasonable number of hours to calculate? What do you want to go up by? 4? Sure, okay. She works 4 hours, and she works 8, and she works a really long day, and she's gone all day, or she's gone for half the day, and she's gone even longer. Sure, there's nothing wrong with that. I mean, because this is daily, we wouldn't want to make the hours any bigger than this. We wouldn't want to go up like by tens, because that really wouldn't make sense. But this is fine. We could have gone up by 2s. We could have gone up by 3s. We could have gone up by 1s. So how much does she get paid here? She gets $110. 4 times 15 and then add 50. How much does she get here? 120 plus 50, she gets 170 bucks. Up here, well, perhaps you can even just fill them in, start filling them in without even using a calculator. Like it's linear, right? This is going up by a constant amount, which means this should be as well. What am I going up by here? 60s. So the next, so 60, 60, another 60 is 230, and another 60 is 290. That's not a bad little payday. I mean, 16-hour day, but she gets almost 300 bucks, which she will lose 40% of to deductions. So as a graph, again, hours worked versus gross pay. Independent variable is hours worked. Dependent variable is gross pay. Well, we went up by 4s for the hours worked, so we might as well go up by 4s on the scale. But we got to be careful with our scale, our vertical scale, because we can't go like, no, I use different numbers, so. Tell me what's wrong with this. What's wrong with that, doing it like that? We can't do it like that. There's something wrong with that. Exactly. We went up by 50 here, and then we started going up by 60s. The scale has to be the same. So we could just change it like so. We go up by 50s. And we're going to have to estimate a little bit. So $0, $50. 4 hours is 110. 8 hours is 170. 12 hours is 230. And 16 hours is 290. So we had this kind of estimate the points a little bit, but again, because we're talking about linear stuff right now, these should, every time you do one of these, they should form a line. Okay, so what did I just do? Yeah, I just did partial variation. No, it isn't, is it? No. No, we're on the last page. Yeah, okay, sorry, I got my pages mixed up. So how do we recognize partial variation? It's going to look like this. Dependent equals constant of variation times independent plus some fixed value. So if there's no fixed value, yeah, just 1 second. If there's no fixed value, it's direct. If there's a fixed value added on, it's partial. Yeah. Alex? Is it always, like, are you always adding a fixed value, or could you also do it? Would that still make it go up? Yes, it would still make it go up. So yes, I believe you can take it away. Like if you had, say, what would be an example where you take away profit, right? You would take away, like it would be how much you sell minus how much it costs you. But that would, well, that would still hopefully generally go up unless your costs are more than your your sales. Okay, so just last Very straightforward question. To rent a mid-sized car, car rental charges $30 a day plus 5 cents per kilometer. Is that direct or partial? It's partial because there's a fixed value of $30 a day. If there was no fixed value, it's direct. And finally, how would you write this as an equation? So let's say C is the cost and K is the number of kilometers you drive. Let's see. How would you set that up in an equation? First of all, which one is the dependent variable? Which one depends on the other? The cost depends on how much we drive. So this is going to go by itself. $0.05 per kilometer. How do I write that? Excellent. 0.05K. Don't write it as 5K because it's expressed in terms of dollars. Okay? 5 cents is not $5. 5 cents is $0.05 plus the fixed cost that we paid of 30 bucks. And notice that matches a partial variation. Okay.